Uh, in the given circuit, the emitter A assumed to have negligible resistance reads 0.1 ampere. The value of R is. Okay, now how we can get the answer to this problem? Now here the only information they have given is here it is the current through the emitter is 0.1 ampere, and here we have 50 ohm and 30 ohm, which is altogether 80 ohm. So we can use V equals IR. So 80 into 0.1 is 8. So here voltage becomes 8 volt, and here it is also 8 volts, right? And now this will be very easy if you can remodify this circuit in your head, something like this. So here we have 12 volt battery, and then I take the R resistor here, and then we have here 20 ohm resistor. So this is R and this is 20, and here we have 80, right? 80. Okay, and here the potential is 8 volt, so it is here also 8 volts, 8 volt. So this is 12 volt. So here 12 means the remaining will be here 4 volt, right? Okay, so now we can find the resistance R by this R divided by here resistance. We want to find the equivalent resistance here. So R divided by, let me find that since these two are parallel, we can get 20 into 80 divided by 20 plus 80, which is 100. So it gives 20 into 80 is 1600 divided by 100, no? So let me write, so 16 into 100 this divided by 100. So 100 cancels off. So here value is resistance is 16 volt, equal resistance 16 ohm. So R divided by 16 is equals to 4 divided by 8. Since this potential divider circuit, these two are series, right? I mean this R and the equivalent here, right? Okay, so here we get R equals, so half into 16, so R equals 8 ohm. Okay, so in the exam paper you should not necessarily draw these figures. You should be able to visualize this. Okay, so here comes the catch. Okay, so to answer this question, it takes less than 1 minute. So first we want to realize this here voltage is zero point 0.1 into 80 means 8 volts. So here it will be 8 volt, right? So remaining 4 volt will be there here because battery gives 12 volts. So 8 volt drops from here, so remaining 4 volts should be from here. So and then next we can write R divided by here the resistance, if we consider this, and the equivalent of this. Okay, those two become series. So here we can get quickly 20 into 80 divided by 20 plus 80. So it it quickly gives, if you are good in maths, it won't take more than 10 seconds to realize. Here the value is 16. Okay, is equals to 4 over 8, right? So R equals half into 16, so R equals 8 ohm. So to get the answer to this question, if you have good practice and good mathematics, I mean, yeah, I mean, you want to get the equivalent of this, no? So you want little good practice in maths as well. It won't take more than uh, 40 seconds maybe to get the answer. Okay. Okay, so the next question, in the given circuit, the potential difference across R2 is 40 volt and the ammeter reads 2 ampere. Okay, so now here they have give two informations. Here the potential is given and here the current is given. Okay, so if we know the current, this current is 2 ampere, so the same current goes through this one, no, this R2, right? Because here the current divides and then again they sum up here and again 2 ampere will be flowing through R2, right? So for R2, if we use V equals IR, so 40 equals 2 into R, so R here R2, sorry, so R2 is 20 ohm, right? So that's the first thing that you have to figure out. Okay, so now we want to find the value of R1, that is the actual problem. Okay, so how can you find the R1? Now for that, what we can do is quickly, so we can use Kirchhoff for this whole circuit, right? So we can use 120 equals I into, okay, 25 plus R2 you calculate, that is 20 plus the equivalent of this, that is 20 R1 divided by 20 plus R1, right? So all we have to do is quickly simplify this equation, and here we know the value of I, which is 2, no, right? Okay, so we get here 2 and 120, okay, 60 is equals to 25 into plus 20, 45 plus 20 R1 over 20 plus R1, and then we can multiply both side by 20 plus R1, so we get 60 into 20 plus R1 is equals to 45 into 20 plus R1 uh, plus 20R. Okay, and this simplification would be easy if I already subtract this 45 from here. Anyway, uh, we can subtract from here as well. So here 20 plus R1 and here 20 plus R1. So we take this to the other side. So we get 60 minus 45, no, which is 15 into 20 plus R1, right? Or else you can take this to here. So 60 minus yeah, I would do like that. Yeah, it will be easier. So 60 minus 45 is equals to 20R over 20 plus R1. R1 here. Okay. So here 15, right? This is 15 and I'm multiplying both side by 20 plus R1. So 15 into 20 plus R1 is equals to 20 R1. So here 5 into 3 and 5 into 4. So 3 into 20 60 plus 3R1 is equals to 4R1, right? So from this we get R1 is equals to 4R1 minus 3R1, it is R1 is equals to 60 ohm, right? So answer is this one. Okay. Here now the very first thing you want to understand, here the current is 2 ampere, then current through this also 2 ampere. So this value R2 is we can find simply using V equals IR. If in case you didn't figure it out this R2 first, when you write the Kirchhoff law to the circuit, you get two unknown values, but we have only one value, one equation, right? So it is infeasible. I mean, we cannot solve the problem, right? So the very important thing you want to understand is to find out the R2 value first here in this case. okay, and then we can put the Kirchhoff to the circuit, so we can find the R1 quickly. Okay, now this problem is not hard, but only it takes some few seconds to do the steps, mathematical steps, to simplify and obtain the answer. Okay. Okay, this question, in the given circuit, the value of I, comma I1, comma I2, I3, and I4 are in amperes. Okay, so now it will be easy if we can find the I first, and then, yeah. Okay, so here the battery is 6 volt, but I also have internal resistance. So if I say the potential difference across the battery is V, so we can write V equals E minus IR, no? So V equals E is 6 volt minus, here I we don't know, into 1. So it is, we want to find the I. So it is very easy. Yeah, the only way to find the I is considering the equivalent circuit, right? That means we want to find the equivalent resistance, because all the resistance is given here, right? So here let's find the equivalent of these two. So it is 6 into 12 divided by 6 plus 12, right? So 6 into 12, I can write 3 into 4 divided by 6 plus 12 is 18. 18 is 6 into 3, no? Right? So here these two cancels, so we get it is equals to 4, right? So here 4 and here 4, 8, right? 4, 4, 8, and 8, 8, we get here 4. So the equivalent circuit, if I consider, it is like this, no? Here battery, so 6 volt, comma 1 ohm, here 4 ohm. Now we can find the current I, right, by using Kirchhoff law. So 6 equals I into 4 plus 6 equals I into 4 plus 1, right? 6, yeah, that is the EMF, and IR terms we have 4 and 1. Okay, so I equals 12 divided by 10. 6 divided by 5 is equals to 12 divided by 10, that is 1.2 ampere. So it has to be start from 1.2, so either first or second is the answer. Okay, right. And now next thing we can find quickly I1, because now we know the potential here, that is V equals 6 minus I is 1.2, right? So that is equals to minus 1, 5, 4.8, no? 4.8 volt. So we can use V equals IR for this 8 ohm resistor. So V equals IR. So we have, yeah, 4.8 equals I1 into 8, right? So this gives I1 is here 8 into 6, no? Like, so point, it is 6, yeah, 0.6, 0.6 ampere. By the way, it is, we should not find this I1 here, right? Because now we have answers only 1 and 2, no? Right? If you consider 1 and 2, the I1 value is the same, no? And also I2 values are same. So it is what we want to find is either I3 or I4 to differentiate, figure it out whether the answer is first one or second one. So here what I have done here is, it's a waste of time, because we know our answer is either 1 or 2. So if you consider these two have the same value, this one I1 and I2 have the same value, so we want to check either I3 or I4, right? Okay, now we know here I1 is 0.6 ampere, right? So here 0.6 ampere, so remaining 0.6 will be flowing through this one, right? So here comes 0.6, right? That means at here I2 is 0.6, and here it will divide into the ratio uh, inversely, no, right? Because these two resistors are parallel, right? So we can write here I, or else we can equate these two potential difference across the I mean these two resistors have the same potential difference, no? So that means we say V equals V, so V here potential V equals IR, so we have I3 into R, which is 6, is equals to I4 into 12. Or else with the, if you have good knowledge, we know I1 to I2 ratio should equals to 1 over R 6 to 1 over 12, no? Like that. Okay, anyhow, we have this relation from here. From here we can write, yeah, we can argue whether the answer is first one or second one, right? So we can see from this I3 should be large. I3 should be larger value, right? So it is answer first one, because if you consider I3 and I4, here 0.4 and 0.2, because we can see this into this should be equals to this and this. Since this is large, so this has to be smaller, right? Right? Okay, so the answer is first one. Okay. Okay, I think